Okay, so here's an example using actually a combination of inclined planes and pulleys. It is example number 4 on the pulleys and tension section of your example problems. In the question, if you read it, it actually says, as seen below, and there is no diagram, but this is the diagram for the situation. So the information you're missing, if you just looked at the example, would be the two angles of 50 degrees and 30 degrees. So imagine you've got some situation where you have a frictionless pulley and a mass hanging over either end of it on an inclined plane. The friction's constant between the two masses in the plane itself, but there is friction, which again makes it a very interesting problem. And each side of the inclined plane is a different angle. And what we're looking for is the acceleration of the system. Now, by now you've seen some pulley questions, and you should know that one of the first things you do, besides drawing a diagram when solving a pulley question, is determine the direction of motion. Now here's what's going to happen. If you pick the wrong direction of motion, you'll end up with a negative acceleration. And normally that just means, you know, you can just solve the problem, or you can just give it the acceleration for the new direction and it's fine. However, in this particular question, because of friction being involved, if you end up with a negative acceleration because you chose the wrong direction of motion, you actually have to restart the problem over again. But I'm not going to set us up for failure, and this one is actually fairly simple to figure out which way it's going to go. So if this system was free to move, you've got 8 kilogram mass here, and you've got a 12 kilogram mass here, and so you can probably imagine with the heavier mass and a steeper angle, it's going to move in this direction. So this becomes what I call my positive direction of motion. And the nice thing about the pulley problems is there's really only one direction of motion, meaning that there's no x and y components we need to worry about. We just need to treat this as moving in one direction, which is this way. Okay, by now as well you've seen the pulley problems, and really you should know that what it involves is setting up a series of equations using free body diagrams for each mass, and you end up with two unknowns, one being acceleration of the system, the other being tension of the connecting cable, which is constant all the way through, and then you go ahead and solve using two equations, two unknowns, whatever strategy you like from grade 10 math. So let's start by doing a free body diagram on either one of the masses. Let's go ahead and do mass 1 first. So I take mass number 1. Here's my mass, and I'm going to draw a free body diagram. Pulling it down will be m1 g sine 30 degrees. Pulling it forward will be tension. T. There is, of course, in this question, another force, and that would be friction. So the friction would be going against the direction of motion, and we've already established that this thing is going to move this way, right? If you're on that side of the inclined plane. So I'm going to have to draw another force in here, which will be Fk. Just quickly remind you, Fk equals F and UK equals mg cos 30. Okay. So that's Fk. So that's quite a mouthful, but it's going to end up in our equation, and really it's not that hard, because if you look at this here, you could actually sub in the numbers right away and solve for it. I'm going to wait and do the numbers a little bit later, but let's do our force balance. So the net force is going to be the forward, which is tension, minus the backwards, which is Fk and m1. Okay. So just to go a step further, I can then say, instead of net force, and that's a net force on 1, I can go m1 times acceleration equals t minus m1 g that's that big Fk that I wrote up at the top, minus M1G. Okay. So that looks like a lot, but you could actually just sub in all the numbers, and I'll leave that to you, and you end up with an equation, 8A, where 8 is the mass M1, equals T minus T minus 53.46. That's rounded, of course, but so I do suggest you go ahead and do that yourself instead of taking my word for it, unless you really feel comfortable with this stuff, but it's always good to practice all. Anyway, so that's our first equation. So we have one equation, we have to come up with another equation that's going to have acceleration and t in it, and of course we'll use a free body diagram on M2 to do that. So, looking at M2, now we're down the other side of the inclined plane. So here's my mass 2, and pulling it down will be that component of gravity, and it will be M2G. Pulling it down, and holding it back will be two forces. One will be tension holding it back, and the second will be friction. And Fk in this case will be M2, where this is my normal force, and Uk, of course, will be the friction. So using the exact same thing we did in the last mass, we can now set up an equation on this side where we say the net force on 2 is equal to the forward minus the backward, so forwards again, it looks like a lot, but really most of it's just numbers and you can just sub it. And this leads us to our second equation, which is 12A, 12 being mass and A is acceleration. And again, I do suggest you go through that math yourself to come up with that equation. But that is what it is. Okay. So that's our second equation. Now we have two equations and two unknowns. So on the next page, we'll go ahead and solve for acceleration. It just asks for acceleration, but because we're keeners, we're going to do acceleration and tension. Okay, so here's what I'm going to do, the strategy I'm going to follow to solve my equations 1 and equation 2. You could do substitution. I'm going to do just add them. I'm going to add equation 1 and 2. So to do that, I can say there's equation 1. And there's equation 2. Just write it in the opposite order, so I have T over T. I add them up, I end up with 20A on this side. T plus negative T is 0. Negative 53 plus 74 is 20.75, giving us acceleration at basically 1. Okay, and really that's the question, and that's all it asks for. Let's just, because you care, solve for tension as well. And to solve for tension, you just take that acceleration and sub. Sub it into equation 1. So 8 times 1 equals 2. .46, we'll just say 61 newtons, and there's our answers. And they're good ones too.